Welcome to the next session on Advanced ANSYS Workbench tutorials. In this session, we will analyze a globe valve for its modal analysis. We will start by double-clicking on the modal module. First, we'll go to engineering data and double-click. Various types of materials used for manufacturing of globe valve are carbon steel, alloy steel, stainless steel, brass, bronze, cast iron, nickel-based alloys, titanium alloys. Now out of this, we will be using stainless steel, brass and bronze as the three materials for analysis, and we will do a comparative analysis of the three. So we will start by going to engineering data sources, general materials. Stainless steel is already available, so I'll just bookmark here by clicking on this plus sign. Now if you check, brass and bronze are not available, so we will click on engineering data sources again. Here I will add material brass. Now we'll give the properties. The first property is density, which is 8490 kg per meter cube. Again, we'll click on brass such that these options open up. We'll go to isotropic elasticity and double click. The value of Young's modulus is 97 gigapascal. So I'll change Pascal to gigapascal and write this as 97. Value of Poisson's ratio is 0.31. We will create the next material, which is bronze. First property we will give is density. Value is 8410. Next, we will click on isotropic elasticity. The value of Young's modulus in gigapascal is 138. Value of Poisson's ratio is 0.42 for bronze. So we have added the three materials. We'll go to project and update project. Once we have added the three materials, we'll go to geometry and right click. Here I'll import the geometry of the globe valve, which is already made with me. Next, I'll go to model and double click. First, we'll go to geometry and click on this plus sign. You can see here, this is the geometry. I'll first go to material assignment. Here it is structural steel, the default material of ANSYS. We will change this to stainless steel. Then we'll go to mesh. Here I'll change the units to meter and I'll give the element size as 0.01 meter. You can make it more finer. I'll click on generate. Now once the mesh is generated, we'll go to model A5. Here I'll right click and insert fix support on this side, apply. Again I'll right click and insert fix support, select the other side, apply. Once we have given the two fixed supports, next we'll go to solution, right click, insert. We'll go to solution. I'll right click and solve. Now once the solution is obtained, you can see here there are 6 lines that you can see. On the vertical axis, we can see frequency. On the horizontal axis, we can see the mode number. So here there are 6 modes. Now how did we get 6? You can go to analysis settings and you can see here max mode to find our 6. You can increase or decrease this number as per your choice. I am leaving it to 6 itself. So I'll click on solution A6 again. This becomes visible. I'll click here, right click, select all. Again right click, create mode shape results. You can see here 6 deformations have been found. So I'll just go to solution A6 and solve for the result. You can see the first result of deformation. The maximum value is 4.122 meter and the frequency is 4084.7 Hz. Now the frequency is quite high, hence the value of deformation is also high. Had this frequency been low, then obviously it is possible that these natural frequencies will not be tapped. So higher value of frequency means your body will be safe at lower values of frequency. Next, we have the total deformation, where the maximum value of deformation is 4.22 meter and the value of frequency is 4567.2 Hz. You can animate and check the pattern of motion of this valve. If this frequency is tapped and this kind of deformation occurs, what kind of motion you will see in this valve. You can also see for the first one by clicking on animation. Then we'll go for the third one. Here the deformation maximum is 4.67 meter for a frequency of 8826.9 Hz. You can see its pattern of motion. Then we'll go for the next one, where the deformation has reduced to 3.9 meter, but the frequency has increased 9155.7 Hz. You can animate and see this pattern of motion of the valve. Then we'll go for the fifth one. The maximum frequency is 12107 Hz, which is quite a high value, and the deformation is 5.81 meters. Last is the deformation 6. The value frequency is 12316 Hz and the deformation maximum is 4.29 meters. You can see its pattern of motion. If this frequency is tapped, then you can see a deformation of this sort in the valve. Now this is all about stainless steel. So now we'll again click on this geometry and change the material to brass. We'll click on solution A6 and solve once again. Let's click on total deformation. The first one, the pattern of motion for all the materials remain the same. So you don't have to animate and check for the three materials separately. Whatever pattern of motion you have observed for the first one, the same thing will be applicable for the second and the third one. What will change is the frequency and the maximum value of deformation. So here the maximum deformation is 3.9 meters for a frequency of 2766.7 Hz. You can see at a lower value of frequency as compared to stainless steel. Here the first value is 2766.7 Hz. Then the second deformation occurs at a frequency of 3093.5 Hz. Maximum value of deformation is 4.03 meters. Then we go for the third one. Here the highest frequency is 5978.8 Hz and the maximum deformation is 4.46 meters. For the fourth one, highest value of deformation is 3.72 meters for a frequency of 6201.5 Hz. For the fifth one, you can see the value of frequency is 8200.4 Hz and the deformation is 5.556 meter. And for the last one, the maximum deformation has reduced to 4.1, but the frequency has continued to increase 8342.3 Hz. Now this is all about brass. We will change the material to bronze and let's see what happens. We go to solution A6 and solve once again. Let's go for total deformation. Here you can see the maximum value is 3.92 meters for a frequency of 3358 Hz. Next, total deformation is 4.04 meters for a frequency of 3787.8 Hz. The third one is 4.475 meter for a frequency of 6894 Hz. Then you can see for the fourth one 3.62 meters for a frequency of 7543.5 Hz. Then 5.25 meter for 9764.1 Hz. And the last one has a maximum frequency of 10,198 Hz, and the deformation is 4.02 meters. Now you can see for stainless steel, the frequency was quite high, and then comes bronze as a safer material, and finally will come brass at the last. So if you have to choose, you should choose a globe valve which is preferably made of stainless steel. Then you can give priority to bronze and then finally to brass. If you have to go depending on its modal value. So with this, I end the session. I hope you understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.